For two sets A and B, show that the Cartesian product of A and B and the Cartesian product of B and A have an element in common if and only if the sets A and B have an element in common. Okay, let us begin. So first what we'll do, we're going to consider an arbitrary element. So let the arbitrary element be denoted by the ordered pair A comma B. So let A comma B be an arbitrary element such that we have the ordered pair A comma B. This is an element of the Cartesian product of A and B intersection with the Cartesian product of B and A. Okay, what does it mean? This simply tells us that the first element of the ordered pair A that is going to belong to, this simply implies that the ordered pair, which is an element in our case, is going to belong to both of the two sets. It's going to belong to the Cartesian product of A and B, and also the same ordered pair A comma B is going to belong to B and A, the Cartesian product of B and A. Okay, now when we say that an ordered pair belongs to the Cartesian product of A and B, this means that the first element A is going to belong to the first set A, and we have the second element, which is B, that's going to belong to the second set, that is B. Similarly, we have A belonging to B and we have B belonging to A. Now what we can do, we can rewrite this statement. So we can combine this and this statement that tells us that we have then element A belonging to the set A, and that same element A also belongs to the set B. And then we're going to combine these two statements. That means we have the set B containing, the element B is contained in the element set, and B is also contained in the set A. Now what does it mean when we say that A belongs to both the set A and B? That simply means that A belongs to A intersection B, and we have the set B belonging to B intersection A. Now this simply tells us that if we have an ordered pair A comma B that is common to the set, the Cartesian product of A and B and Cartesian product of B and A, then we have that element A which is going to be common to both A and B, and also we have B common to both B and A. We can also solve this from the other way around. Suppose we consider two arbitrary elements C and D such that C belongs to the set A intersection B, and we have that same we have the other element D which also belongs to A intersection B. In other words, what we are saying that C and D are common to both A and B, A intersection B. Now if we break it down, this means that C belongs to the set A and C belongs to the set B, and the other statement means that the element D belongs to the set A and we have the element D belonging to the set B. Now this means that we can rewrite the statement as C belonging to the set A, and we can consider D belonging to the set B. Next we can combine these two and write it as, and we have C belonging to the set B and we have D belonging to the set A. What does it mean? We are saying that C belongs to set A and D belongs to set B. We can say that the ordered pair C comma D, that's an element that belongs to the Cartesian product of A and B. And the other statement simply means that if we have C belonging to B and D belonging to A, we have the Cartesian or we have the ordered pair C comma D which belongs to the Cartesian product of B and A. Now when we combine these two statements, which simply means that we have the ordered pair C comma D that belongs to the Cartesian product of A and B intersection with the Cartesian product of B and A. Fine. So here combining the both of the two statements, this is the statement number 1 that we have verified, and then we have the statement number 2 which we have also verified. So combining both statement 1 and statement 2, we can say that for two sets A and B, the sets the Cartesian product of A and B and the Cartesian product of B and A have an element in common. The element could be either the ordered pair A comma B or the ordered pair C comma D, if and only if A and B have an element in common.